Hi everyone, welcome to Build More Robots. So in my never-ending quest to rebuild the original Parallax Boebot, I have redesigned the original control board into something that looks more like this. Tonight I want to talk about two new chips that I'm going to integrate into the next design. And the first one is this really cool little I2C multiplexer that's made by Texas Instruments. And it's the TCA9548A. So as you can see, I've already got it mounted onto this little prototype board and then hooked into the different I2C buses and power supplies. It's a really neat chip. I'm going to show you on this over here, where it connects into the original I2C bus here, and it's 5-volt tolerant. And then it provides you with 8 different I2C channels. And if you wanted to have even more of these chips hanging off the same I2C bus, you can set different addresses with the A0, A1, and A2. The only thing that's kind of crucial on this is that the VCC has to be selected from a table so that you can use it for voltage translating. So if you're going from a 5-volt I2C bus and you're going to, like I am, I'm going over to a 2.8-volt I2C bus. And you have to choose a proper VCC. So it isn't hard. I'm just using 3.3 volts on mine, which is pretty common. And that allows me to talk to all the different devices that I'm going to use. So the goal is to actually connect the little sensor, the one I'm going to talk about next, to these different channels. As you can see, there's 8 different channels, so I can have 8 different sensors, although I'm probably not going to use all 8. So this is the VL6180x. It's a really neat little chip that has a laser in it and uses time of flight, and it sends out a laser beam and then it figures out how long it takes for it to come back. Although that's not entirely accurate because you can't really measure the speed of light, but they do some pretty cool things to make it work. And you get the distance back in millimeters, and it's very accurate. And unlike some of the other sensors that we've used that use infrared, the color and texture of the object doesn't really have much effect on it. So that was something really desirable to me, so I wanted to incorporate that into the new design. I originally experimented with this little prototype board from Adafruit, and it already has all the voltage translation and a 2.8 volt regulator and everything built into it. So that's great, except I really have to build everything that I put on my robots from scratch. So what I did was I took these printed circuit boards and I just designed a printed circuit board that fit onto the Boebot. And then I cut some of them up, as you can see. And some of them have the chip mounted on them, and some of them don't. And so what I'm going to do is what I did do is I took solder paste and I put it on the little pads, and then I use this hot plate. You can pick them up from different distributors for under $100, and you get it up to about 380 degrees. Depends on your solder paste, and also you should look at your data sheet of your different devices to make sure that you're not going out of specs. And once it gets up to the correct temperature, you put the board on there with the solder paste and the device on it. Keep an eye on it. Let it go through the solder profile, and then you take the board off. So don't use your fingers because that would hurt a lot. And then if everything went well, you should actually have a working board. So it does take a little bit of practice, and that's why you can see that I have a bunch of them that are already put together. But I'm pretty happy because this first one I tried works. So yep. So if everything works out well, I'll have a whole array of these sensors around the outside of the old Boebot. Well, thank you for listening. You guys have a nice day, and thank you for visiting Build More Robots.